Welcome to this quick introduction to Rust, the systems programming language known for safety, speed, and concurrency. Rust is a modern language focused on memory safety without a garbage collector. It's designed to prevent common bugs like null pointer dereferencing or data races in multi-threaded applications. One of Rust's core features is its ownership system, which ensures memory safety at compile time. Rust is great for systems programming, game development, and even web development thanks to its fast performance and safety guarantees. Here's a basic Hello World program in Rust. Notice how it uses println for output with an exclamation mark because it's a macro. That's a quick look at Rust. Stay tuned for more tutorials on Rust's unique features like ownership, borrowing, and more. In this video, let's write your first Rust program. We'll start simple with a Hello World example. To get started, create a new Rust file with the rs extension. Then write a simple main function. Here, fn defines a function, and main is the entry point for every Rust program. The println is a macro that prints text to the console. The exclamation mark indicates it's a macro, not a regular function. To run this program, open your terminal and type cargo build to compile it. Then run the compiled file by typing cargo run. This will print Hello World to your terminal. Congrats! You've just written and run your first Rust program. Stay tuned for more quick Rust tutorials. In this video, let's talk about variables and mutability in Rust. In Rust, variables are immutable by default, meaning their values cannot be changed once assigned. Here, let x equals 5 creates an immutable variable. If you try to change it, Rust will throw an error. To make a variable mutable, use the mut keyword like this. Now, you can modify the value of x because it's mutable. Immutability helps prevent bugs in your code by reducing unintended changes, but mutability is available when needed. That's the basics of variables and mutability in Rust. Stay tuned for more quick Rust tips. In this video, let's take a quick look at Rust's data types. Rust has several built-in data types divided into scalar and compound types. Scalars include integers, floating point numbers, booleans, and characters. Compound types in Rust include tuples and arrays. Tuples can group different types together, while arrays hold multiple values of the same type with a fixed length. Rust is strongly typed, but it also has type inference, so you don't always need to annotate the type explicitly. Rust will infer the type based on the value if you don't specify it. That's a quick look at data types in Rust. Stay tuned for more Rust tutorials. In this video, let's explore constants and shadowing in Rust. Constants are values that are set once and cannot be changed throughout the program. Unlike variables, constants are always immutable and must have a type annotation. Constants are defined with the const keyword and can be used globally within your code. Here, maxpoints is a constant of type U32. Shadowing allows you to redeclare a variable with the same name, but with a new value or even a different type. This is useful when you want to transform a value without mutating it directly. Rust allows shadowing instead of mutability. Remember, shadowing lets you redeclare a variable, even with a new type. Mutability only allows you to change the value, but not the type. That's a quick look at constants and shadowing in Rust. Stay tuned for more short Rust tutorials. In this video, let's quickly dive into string handling in Rust. Rust has two main string types, and str, which is an immutable string slice, and string, a growable heap allocated string. You can easily convert between an str and string using methods like to_string and as_str. You can manipulate strings by pushing or concatenating them. That's the basics of handling strings in Rust. Stay tuned for more Rust tutorials. In this video, let's take a quick look at tuples in Rust. Tuples in Rust are a way to group multiple values of different types into a single compound type. Here, the tuple person contains a string slice, an integer, and a floating point number. You can access individual elements of a tuple using dot notation with index numbers. Rust also allows destructuring tuples into separate variables. That's the basics of tuples in Rust. Stay tuned for more Rust programming tips. In this video, let's explore arrays and slices in Rust. Arrays in Rust are fixed size, meaning they hold a specific number of elements of the same type. Here, we have an array of 3 integers. The type is i32, and the length is 3. You can access array elements by their index, starting at 0. Slices let you reference a section of an array without taking ownership. They are dynamically sized. Here, the slice references the first 2 elements of the array, but the original array stays intact. That's a quick look at arrays and slices in Rust. Stay tuned for more Rust tutorials. In this video, let's dive into functions in Rust. Functions in Rust are defined using the fn keyword, followed by the function name and parameters. To call a function, simply use its name followed by parentheses, passing any required arguments. Functions can also return values. To do this, specify the return type after the parameters. That's a quick overview of functions in Rust. Stay tuned for more Rust programming tips. In this video, let's clarify the difference between expressions and statements in Rust. A statement is an instruction that performs an action but does not return a value. Example, variable declarations are statements. An expression is a piece of code that evaluates to a value. For example, mathematical operations are expressions. You can combine statements and expressions. Here's an example where an expression is used within a statement. That's a quick look at expressions and statements in Rust. Stay tuned for more Rust programming insights. In this video, let's explore control flow in Rust using if and else statements. The if statement allows you to execute code based on a condition. You can use else to execute code when the condition is false. To check multiple conditions, use else if. That's a quick overview of control flow using if and else in Rust. Stay tuned for more Rust programming tips. In this video, let's explore pattern matching using the match statement in Rust. Match is a powerful control flow operator that allows you to compare a value against a series of patterns and execute code based on the matching pattern. Here's a simple example where we match an integer. You can also match ranges using the match statement. Another powerful feature is matching against enums. Let's define a simple enum and match its variance. That's a quick look at pattern matching with match in Rust. Stay tuned for more Rust programming tutorials. In this video, let's explore loops in Rust. The simplest way to create an infinite loop is by using the loop keyword. You can also create loops that run while a condition is true using while. For looping over a range or collections, use the for loop. You can also iterate through collections like arrays or vectors. That's a quick overview of loops in Rust. Stay tuned for more Rust programming insights. In this video, let's dive into ownership in Rust, a key concept that ensures memory safety. In Rust, every value has a single owner, which is the variable that holds it. When the owner goes out of scope, the value is dropped and memory is freed. When you assign a value to another variable, ownership is transferred. The original variable can no longer be used. You can borrow ownership temporarily using references. This allows you to use a value without taking ownership. You can have mutable references, but only one mutable reference is allowed at a time to prevent data races. That's a quick overview of ownership in Rust. Stay tuned for more Rust programming insights. In this video, let's explore borrowing in Rust, a crucial aspect of its ownership system. Borrowing allows you to use a value without taking ownership of it. This enables multiple parts of your code to access the same data safely. When you borrow a value immutably, you can read the data, but you cannot modify it. You can also borrow a value mutably to allow modifications. However, Rust enforces that only one mutable reference is allowed at a time. Remember these rules. You can have either multiple immutable references or one mutable reference at a time, but not both. These rules help prevent data races and ensure memory safety. That's a quick overview of borrowing in Rust. Stay tuned for more Rust programming tips. In this video, let's explore lifetimes in Rust, a key concept for ensuring memory safety. Lifetimes are a way for Rust to track how long references to data are valid. They help prevent dangling references and ensure that data lives long enough for its references. You can annotate lifetimes using a single quote followed by a name like Here's a simple example. Rust uses lifetime elision rules to simplify function signatures. For example, if the function has one input reference, the return type will use that reference's lifetime. If you have references with different lifetimes, Rust can infer the shortest lifetime to ensure safety. That's a quick overview of lifetimes in Rust. Stay tuned for more Rust programming insights. In this video, let's dive into structs in Rust, which are used to create custom data types. A struct is a composite data type that allows you to group related data together. Think of it as a blueprint for creating complex types. You can create instances of a struct by specifying values for its fields. You can access the fields of a struct using dot notation. Rust also supports tuple structs, which are similar to tuples but have a name. You can define methods for structs using impl. This allows you to add functionality related to the struct. That's a quick overview of structs in Rust. Stay tuned for more Rust programming insights. In this video, let's explore enums in Rust, a powerful way to define types that can have multiple variants. Enums, short for enumerations, allow you to define a type by enumerating its possible values. This is useful for representing data that can be one of several options. You can create instances of an enum and match against its variants to handle different cases. Enums can also hold data. This allows you to attach additional information to the variants. When matching enums that hold data, you can destructure the variants to access the contained values. That's a quick overview of enums in Rust. Stay tuned for more Rust programming insights. In this video, let's explore the option enum in Rust, which is used for values that can be either some value or none. The option enum is defined in the Rust standard library and is a powerful way to handle optional values safely. You can create an option by wrapping a value in some or using none for the absence of a value. Pattern matching is often used to handle option values safely. You can use unwrap to get the value inside an option, but be careful. It will panic if the value is none. Alternatively, you can use unwrap underscore or to provide a default value if it's none. You can chain methods like map to transform the value inside an option, and underscore then to chain computations that also return an option. That's a quick overview of the option enum in Rust. Stay tuned for more Rust programming insights. In this video, let's explore the result enum in Rust, a powerful way to handle errors in a safe and expressive manner. The result enum is defined in the Rust standard library and is used for functions that can succeed or fail. You can use result to return either a success value with awk or an error value with error. Pattern matching is commonly used to handle the outcome of a result. You can use unwrap to get the value from awk, but it will panic if it's an error. Alternatively, you can use unwrap or to provide a default value if it's an error. You can chain methods like map to transform the value inside a result, and then to chain computations that also return a result. That's a quick overview of the result enum in Rust. Stay tuned for more Rust programming insights. In this video, let's explore error handling in Rust, a language that encourages handling errors safely and explicitly. Rust uses the result enum to represent operations that can succeed or fail. This makes error handling explicit and prevents unexpected failures. One common way to handle errors is by using pattern matching to process the result. If you're sure a function will succeed, you can use unwrap, but be aware it will panic if there's an error. A safer alternative is expect, which lets you provide a custom error message. To make error handling cleaner, Rust provides the write single quote operator, which automatically returns errors from a function. You can also create custom error types to represent specific kinds of errors in your application. That's a quick look at error handling in Rust. Stay tuned for more Rust programming insights. In this video, let's dive into traits in Rust, which allow you to define shared behavior for different types. A trait is like an interface in other languages. It defines a set of methods that types can implement. You can implement a trait for a specific type by defining the methods inside an impl block. Traits can also be used to define function parameters, ensuring that the argument implements the required trait. To make generic functions more flexible, you can use trait bounds to specify that a type must implement a certain trait. Traits can also provide default method implementations, allowing you to override only specific methods if needed. That's a quick look at working with traits in Rust. Stay tuned for more Rust programming insights. In this video, let's explore generics in Rust, which allow you to write flexible and reusable code for different types. Generics enable you to define functions, structs, enums, or methods that work with any data type, ensuring type safety. Let's look at how to define a generic function. The largest function here works with any type that implements the partial or trait. Generics can also be used in structs. Here's a struct point that can hold any type. Enums can also use generics to handle different types. Here's an example with the option enum, ensuring they implement certain behavior. That's a quick overview of generics in Rust. Stay tuned for more Rust programming insights. In this video, let's explore impl blocks in Rust, which allow you to define methods and associated functions for your types. An impl block is where you implement methods for a struct or enum. It's how Rust enables object-oriented programming. Inside an impl block, you can define methods that operate on the data inside a struct. These methods take and self as a parameter. You can also define associated functions which don't need an instance of the struct. They're often used as constructors. Rust allows you to have multiple impl blocks for the same type, helping organize your code better. You can also implement traits for your types using impl blocks. Here's an example implementing display for rectangle. That's a quick overview of impl blocks in Rust. Stay tuned for more Rust programming insights. In this video, we'll explore trait bounds in Rust, a feature that allows you to specify what traits a generic type must implement. Trait bounds are used in generics to ensure that a type implements a specific trait, enabling certain behavior in your code. Here's a simple function that requires the generic type to implement the display trait, which allows it to be printed. You can also specify multiple trait bounds to require that a type implements more than one trait. When there are many trait bounds, you can use a where clause to make the code more readable. Trait bounds can also be applied to structs. Here's an example where a generic struct can only hold items that implement display. That's a quick look at trait bounds in Rust. Stay tuned for more Rust programming insights. In this video, let's explore closures in Rust, a way to create short, anonymous functions. A closure is a function-like construct that you can define in place and can capture variables from its surrounding environment. Closures can capture variables from their surrounding scope, which makes them flexible. Rust can infer the types of parameters and return values for closures, making the syntax concise. You can pass closures as arguments to functions, allowing for more functional programming patterns. Closures can borrow, mutate, or take ownership of captured variables, depending on how they're used. That's a quick overview of closures in Rust. Stay tuned for more Rust programming insights. In this video, let's explore iterators in Rust, which allow you to process sequences of data efficiently. An iterator in Rust is a trait that allows you to process elements from a collection one at a time. Rust provides common iterator methods like next, right single quote, map, right single quote, and filter, right single quote for transforming and processing data. You can also use a for loop to iterate over a collection, which automatically consumes the iterator. Rust allows you to chain iterator methods to perform multiple transformations in a single line. You can also create custom iterators by implementing the iterator trait and defining the next, right single quote method. That's a quick look at iterators in Rust. Stay tuned for more Rust programming insights. In this video, let's explore how to work with for loops and iterators in Rust for efficient data processing. A for loop in Rust is the simplest way to iterate over a collection like arrays or vectors. Under the hood, the for loop uses the IntoIterator trait, which converts collections into iterators. You can chain iterator methods like map and filter to transform data during iteration. You can use iterators directly in for loops, giving you more control over the iteration. You can iterate by reference iter, by mutable reference iter mut, or by value into underscore iter, depending on how you want to use the data. You can create custom iterators and use them in a for loop by implementing the iterator trait. That's how you work with for loops and iterators in Rust. Stay tuned for more Rust programming insights. In this video, let's explore how to use pattern matching with if-let and while-let in Rust for more concise and readable code. If-let is a simpler way to match patterns for specific conditions without using a full match statement. Here's how if-let simplifies what would otherwise be a more verbose match statement. You can also combine if-let with an else block to handle cases where the pattern doesn't match. While-let allows you to continuously match a pattern inside a loop, making it useful for iterating through options or results. Similar to if-let, while-let makes loops more concise when matching a pattern repeatedly. You can combine pattern matching with additional conditions using both if-let and while-let. That's a quick overview of pattern matching with if-let and while-let in Rust. Stay tuned for more Rust programming tips. In this video, let's dive into one of Rust's biggest strengths, memory safety without a garbage collector. Memory safety means preventing issues like use after free, dangling pointers, and data races that can cause crashes or unpredictable behavior. Rust's ownership model ensures that only one variable can own a piece of data at a time, while borrowing allows temporary access. Rust prevents dangling pointers by enforcing strict lifetime rules, so references are always valid. Rust enforces borrowing rules to prevent data races by ensuring you can't have multiple mutable references at once. Rust prevents data races by ensuring safe memory access, even in concurrent programming, with its ownership and borrowing rules. That's how Rust guarantees memory safety without a garbage collector. Stay tuned for more Rust programming insights. In this video, we'll learn about slices in Rust, a powerful way to reference parts of collections. A slice in Rust is a reference to a contiguous sequence of elements in a collection, like an array or a vector. Slices are references, so they don't own the data they point to. They only borrow the section of the collection. You can use mutable slices to modify part of a collection, making slices flexible. String slices work similarly and are a common use case in Rust. They allow efficient, partial access to strings. You can use methods like len on slices, and indexing works just like with arrays and vectors. That's how slices work in Rust. Stay tuned for more Rust programming insights. In this video, let's explore how Rust handles strings and UTF-8 encoding, ensuring safe and efficient text handling. Rust strings are always valid UTF-8, ensuring you can work with any language's text safely and efficiently. In Rust, string is a heap-allocated growable string, while str is an immutable string slice, typically used for borrowed data. You can iterate over a string by its UTF-8 characters, which are different from bytes due to encoding. Rust strings can also be accessed as raw bytes, useful when you need lower-level control. String slicing is allowed in Rust, but since strings are UTF-8, slicing must always occur at valid character boundaries. That's how Rust handles strings and UTF-8. Stay tuned for more Rust programming tips. In this video, we'll explore error propagation in Rust, making it easy to handle errors in a clean and concise way. Error propagation in Rust uses the result type, allowing functions to return either awk for success or error for failure. Rust provides the write single quote operator to propagate errors without explicit match statements, making the code cleaner. If the function returns error, the write single quote operator automatically propagates the error up the call stack, making it easier to handle. You can also propagate different types of errors using the from trait, allowing you to combine errors from different sources. You can create custom error types and still use the write single quote operator for error propagation in a structured way. That's a quick look at error propagation in Rust using the write single quote operator. Stay tuned for more Rust tips. In this video, let's learn how Rust uses modules to organize code and manage scope. Modules in Rust are used to group related functions, structs, and other items together, helping keep code organized. You define a module using the mod keyword. Items within a module can be public or private by default. By default, everything inside a module is private. Use the pub keyword to make functions, structs, and enums accessible outside the module. Modules can also be split into separate files to keep large projects organized. The module file name corresponds to the module name. Modules can be nested within other modules for even better organization, and you can access items using the path. That's how Rust modules help organize your code. Stay tuned for more Rust programming tips. In this video, we'll explore vectors in Rust, a versatile and dynamic collection type. A vector in Rust is a resizable array that can store multiple values of the same type, offering flexibility for managing collections. You can create a vector with initial values using the write single quote macro. Vectors are dynamic and allow you to add elements using the push method. You can access elements in a vector using indexing, similar to arrays. Just remember to stay within bounds. You can iterate over vectors easily using a for loop to access each element. You can remove elements using the pop method, which removes the last element and returns it. Vectors can be sliced just like arrays, providing a view into a portion of the vector. That's a quick overview of vectors in Rust. Stay tuned for more Rust programming insights. In this video, we'll dive into hash maps in Rust, a powerful collection type for storing key value pairs. A hash map is a collection that maps keys to values, allowing for fast lookups based on the key. You can create a hash map with initial values using the collect method along with tuples. You can insert key value pairs using the write single quote method. If the key already exists, it will update the value. To access a value by its key, use the get method, which returns an option type. You can remove a key value pair using the remove method, which also returns the removed value. You can iterate over a hash map using a for loop to access both keys and values. To check if a key exists in a hash map, use the contains key method. That's a quick overview of hash maps in Rust.